Good morning, everyone, and welcome again to the MineWarp podcast, the podcast where we try to stretch your minds and look at the warp speed at which innovation and new things are happening in the natural resources industries. We're excited about the growth in the podcast, and we'd like to remind you to like and share alike and tell your friends and your colleagues if you find this useful or interesting at all. Thank you for the time that you spend with us. The topic of artificial intelligence and its application to the mining industry and mining problems is not a new one. And yet there seems to be a general misunderstanding or even maybe skepticism about the level of success that we've been able to achieve so far. Many executives and I guess even engineers will make it off as a fad or maybe a bridge too far. Sometimes because they live in the weeds of daily mining and know about the obstacles in the way of successful AI projects. But sometimes, and arguably even mostly, it's also because people don't really understand what we mean by AI and artificial intelligence. And so some of the more well-known problems maybe that we've already attempted to solve with the application of advanced analytics of various types are actually already in use in many mining companies, and not only mining companies, but all around us. Things like intelligent digital virtual assistants. Just think of Siri and Google Assistant and so on, and natural language agents. If you look at the speed and the accuracy, for example, of translation capabilities offered by Microsoft Teams and PowerPoint and so on. Image processing is something that's advancing a lot in mining, looking at the way that material is sorted and assets are tracked and so on in mines. That's actually a big area of advanced analytics or artificial intelligence application. And then simulation and optimization in mine planning, where mines are slowly but surely becoming more responsive to replanning triggers and more agile in the way that they create new schedules to capitalize on the hyper-awareness of the working environment, is also on the rise. Today, we have an expert in all things artificial intelligence, and someone, I guess I'd also argue, is not too far from the top of the heap when it comes to natural intelligence. Doctor Ali Soofastaei. I hope I pronounced that correctly, Dr. Ali, and if it's okay if I just call you Ali. He's an artificial intelligence industrial global project leader at Vale's Artificial Intelligence Center, and he joins us from Brisbane in Queensland, Australia. Welcome to the MineWarp podcast, Ali.
Thank you so much, Impai, and hello everyone, and thanks for having me today. I'm so excited to be with you today, speaking about the artificial intelligence application as a new technology in mining industry. This is the industry that I have a chance to work in for about 15 years right now, and so I'm so excited, and hopefully we can have a good conversation about the AI application and the future mining or mining 4.0 today.
Yeah. So Ali, as a global project leader, someone who is a noted professional in AI, that sounds very interesting. But what does it take to kind of step into this kind of role? Why don't you just tell us a little bit about your background, maybe academically and otherwise, professional? How did you come to be in the position that you're currently in?
Perfect. Yeah, my background is mining engineering, and I had a chance to complete my master and my PhD in the field of AI application in mining at the University of Queensland. Is one of the biggest and oldest university in Australia, and I completed my thesis to improve the energy efficiency in surface mines by using some types of prediction and optimization application. But this is just the starting point of my journey. And it returns to the many years ago when nobody knows how we can use AI in the mining industry. So it was a dream. I'm speaking about 2010 or 2009. when I offered my proposal to the big mining companies in Australia, I can remember the manager just was laughing. What do you want to do, Ali? We are working in the earth, not in the moon. I was so excited to do this because I tested this type of the models and this application in oil and gas when I was completing my bachelor in mechanical engineering. So I had a chance to work with the different types of the AI application to improve energy efficiency in oil refineries. And I delivered my results practically working for Shell. So, but I wanted to test, my chance again, but in the different industry, in different country. So this was the beginning point. And I can remember Australian federal government in 2010 decided to improve the energy efficiency in all industries. And they have a comprehensive program named EEO, or Energy Efficiency Opportunities. And they wanted to reduce the greenhouse gas emissions in Australia and also improve the energy efficiency. But in mining industry, they don't have any idea how they can improve the energy efficiency. So since I didn't have any prepared thesis title for my PhD, I was looking for any opportunity. Said, okay, we have this opportunity, energy efficiency opportunities program, is as a federal governmental program, and also we have AI as a tool. I was thinking how we can combine these two subjects together. And I found that hauling operation consumes a huge amount of energy in the surface mines. For example, one haul truck in the mine normally consumes about 110 liter per hour, and this type of the trucks working 24 hours in the mine site. And big companies same as BHP, Rio Tinto, Anglo American, Vale using this type of the truck normally in the mine sites, and each fillet has more than 100 truck. So it was the pain point. So I focused on this pain, said, okay, we have this problem. Now, how we can use AI? But the first step was prediction, because we didn't know how we can predict the consumed fuel by the truck in the surface mines. So I made an initial plan and project sponsored by BHP Billiton to predict the whole truck fuel consumption. And it was a very successful project. But when I presented my results, mine managers were so excited. Oh, Ali, you did a great job. Now we can predict the fuel consumption by using artificial neural network. But what's the point? You can predict, but we cannot we cannot decrease the fuel consumption. You spend a lot of time to make the prediction model. Said, okay, this is a new challenge, but I have a solution for that. I started another initiative to focus on optimization. I identified more than 35 effective parameters on a whole truck fuel consumption, and I made a model based on the genetic algorithm fed by the fitness function created by ANN to optimize.
Just for those listeners who don't know, an ANN is an artificial neural network, right?
Yes. We combine artificial neural network with the genetic algorithm. For prediction phase, we use ANN, and ANN could make the fitness function between consumed fuel by truck and 10 effective parameters. And then I fed this fitness function to the genetic algorithm to optimize these parameters. But I focus on the controllable parameters and the parameters that we have a chance to collect data for them. So I completed this application and I presented to the BHP. Okay, I did this job for you. And now you can predict and you can optimize the parameters. And at the end, the result is increasing the energy efficiency of whole trucks. But as you know, some type of the magic application needs to validate. And I had to travel across Australia, in Western Australia, in Queensland, to test my model in different conditions for different companies. And also I had a chance to work in the United States, in the north of Arizona. And I tested my model in different areas, and the result was excellent. And now, just I want to say the end of the story, PHP and Vale using this application every single day in a couple of nominated mine sites.
So you've really grown from something that is potential or that had potential to actual mining companies seeing the reality of that potential and adopting it in real time in their operations.
Yes, exactly. Exactly.
Oh.
So, and the beauty of this application was that it was flexible to adjust with the new technology, same as the autonomous fillets. So later, maybe I can explain for you that the different dimensions of maturity, but we focus on technology, people, system, and data, and now we can use this application for the manual operational mine sites and in autonomous fleet as well. But I wanted just to continue because I don't like to just focus on one case study. Yeah, when I deliver this application and show the power of AI in mining industry, I wanted to discover more initiatives. So I moved from hauling to the loading, blasting, drilling, crushing, and milling.
Right.
And I made an integrated model using AI to not only connect all of this operation together, but also having the optimization method, as in the integrated optimization method, to create a balance between the cost of the projects and between the benefit that we can reach. And it is what in the mining, but later I received opportunities from Vale because I'm working as a AI program leader in Vale. So they offered me other opportunities to think about how we can use AI through the mine value chain, from exploration to the marketing. And in some cases, we can reach to the billion dollar saving, not just thinking about 1 million or 2 millions. Now I'm speaking about using AI for marketing and for shipping. Now I'm leading a couple of projects for Vale, but I believe that this door is still open and we have a huge room of opportunities to can use AI.
That's an incredible history. And as you say, the opportunities are not small opportunities. They are really, really big. But I do still think that there's this certainty from most people when it comes to AI and ML and optimization and simulation and search algorithms and et cetera, et cetera. I mean, these are terms that most people are not necessarily very comfortable with, if I can put it like that. So maybe you can just give us a layman's term definition, if you will, of what is the difference between artificial intelligence and machine learning, two specific terms that we hear very often, specifically in mining.
Perfect. It's a good question because every single day I receive this question from my audience. Ali, what's the difference? And I can summarize. Yeah, it's a very general question for the people. But yeah, I can explain what is exactly AI and what's the meaning of machine learning. Artificial intelligence and machine learning are the part of computer science that are correlated with each other. These two technologies are the most trending technologies which are used for creating intelligent systems. Also, these are two related technologies, and sometimes people use them as a synonym for each other. But still, both are the two different terms in various cases. AI is a bigger concept to create intelligent machines that can simulate human thinking capability and behavior.
Okay.
Whereas machine learning is an application or subset of AI that allows machines to learn from data without being programmed clearly. Artificial intelligence makes a computer system that can mimic human intelligence. It consists of two words, artificial and intelligence, which means a human-made thinking power. So we can say AI is a technology using which we can create intelligent system that can simulate human intelligence.
Yeah.
But
Yeah.
and the artificial intelligence system doesn't require to be pre-programmed. Instead of that, they use such algorithms which can work with their own intelligence.
Yeah.
It involves machine learning algorithms such as reinforcement learning algorithm and deep learning neural network and so on.
Mhm.
And based on capabilities, AI can be classified into three types: weak AI, general AI, and strong AI. Currently, we are working with weak AI and a little general AI, but the future of AI is a strong AI,
Right.
for which it is said that it will be intelligent than humans.
Yeah. Yeah.
But machine learning, or ML, is about extracting knowledge from the data. So
Yeah.
we can say ML is subfield of AI, which enables machines to learn from past data or experiences without being clearly programmed. Machine learning uses a massive amount of structured and semi-structured data.
Right.
And ML models can generate accurate results or give predictions based on the historical data.
So if
But in
I understand you correctly, then if I look at AI, people will have run into AI, for example, in the when they use Siri. It supports things like chatbots and expert systems and these humanoid robots. Whereas maybe the most common applications of machine learning that everyday people will run into is when I use Netflix and it tells me, I think the next movie that you will want to look at is this one based on what you have seen before. I mean, that's a machine
exactly.
learning. Is that more or less accurate?
Yes, definitely. Just if I want to clarify the difference between machine learning and AI, as a bullet point, I can
Yeah.
say machine learning is a subset of AI which
Okay.
allows a machine to automatically learn from historical data without
Yeah.
programming, okay?
Okay.
But artificial intelligence is a technology which enables a machine to simulate human behavior. And the goal of machine learning is to allow machines to learn from data so that they can give accurate output. But the goal of AI is to make a smart computer system like human to solve complex problems. In machine learning, we teach machines with the data to perform a particular task and give accurate result. But in AI, we make intelligent system to perform any task like human. So,
Yeah.
but
Yeah.
machine learning has a limited scope, but AI has a very wide range of scope. But the problem is that now we are using the weak AI. But hopefully in the close future, when we will have access to the strong AI, now machines not only can lead the human, but also can think much more better than human.
All right. Yeah, there's going to be lots of interesting discussion about how to assess who thinks best. But here we go. I've got to so maybe returning to some of the work that you've done. You talked about some of the projects and when you talked about the whole truck optimization for the purpose of energy and greenhouse gas optimization and so on. I wanted to ask you about that. Did your study also look into the external factors beyond the efficiency of the machine? For example, the optimal whole road network design, to do, for example, selection of the optimal haulage truck if I have a given mine design, or traffic optimization, or real-time grade control, and so on? Or was it mostly about the road surface and the haul truck and let's call it the friction related items there?
This is a very good question because, as I told you, we nominated more than 35 effective parameters on the whole truck fuel consumption, and we categorize these parameters in different groups. For example, some parameters related to the truck design, okay? For example, the shape of the body and the size of the tire and something like that. Some parameters related to the mine planning, same as the slope of the road, the number of the truck in the fleet, and so on. And the other parameters can be categorized related to the operation and maintenance as well. So we have different groups, and the model can simulate and can use all of these different types of the parameters at the same time from different sources. We can simulate the fuel consumption and optimize these effective parameters from different sources. For example, we are working with the rolling resistance. It means that the friction between the tire and the surface. We are focusing on the grade resistance is related to the slope of the road. We are optimizing the dispatching system to avoid any truck bunching in the fleet, because as you know, we have two types of the truck in the fleet, a heavily loaded truck and lightly loaded truck. Based on the current technology for loading, it's not possible to put the same load in the same truck. So heavily loaded truck needs to move slowly, so the lightly loaded truck will be bunched behind this type of the truck. But this application can help to avoid this type of the bunching in the fleet. We are using different parameters from different sources. But the key point here is that mining operation team is looking for some optimized parameters for the variable that they can control them. Okay. For example, if my model suggests to change the body of the truck, it's not possible. But if my model can optimize the truck speed in different road segments, it's possible because the driver can change the velocity of the truck or the speed of the truck. If my model can predict something for rolling resistance, it's possible to change because we can change the road maintenance interval to control the resistance. So we are looking for making an applicable application based on AI for the mining. We don't like, to think about the huge amount of the parameters when we cannot control or change them in the real case.
Yeah, so it's got to be useful, not only academically interesting.
Yes. And the beauty of my work is that I came from universities. I have a lot of academic background, and now I'm leading PhD students at different universities across the world to complete their thesis as a volunteer job. Okay. But I'm working with the universities to make sure I can suggest some updated scientific solutions to solve the practical problems in industry, because we are walking in the edge of the knowledge and we need the combination of science and industrial experience. So this is the beauty of my job, and I love it because I have a chance to work with the big research centers across the world and also working with the different mine sites and industrial managers.
Yeah, and then when we talked earlier, and you just touched on that in your introduction as well, when you talked about the opportunities that exist beyond the actual mine, in the downstream value chain, looking at shipping, for example, there seems to be many opportunities for cost saving. You mentioned work that you did in demand prediction and price prediction, which are both subject to extreme levels of unpredictability, or at least it feels like that. But have you done any work to obtain an integrated model to improve the uncertainties associated with ore body variance, which influences the supply, as well as combines that with the lack of predictability in the sales and marketing side? Do you think it's feasible, or have you worked at such an integrated cross-value chain model yet?
Yes, it's some of my current projects that I'm working for Vale, and I'm so glad to say Vale has been, ranked between the 50 innovative companies in the world. I'm speaking about all industries.
Yeah.
And between the mining companies, Vale has been ranked as the first innovative company. It means that we are pioneer in the field of using AI and advanced analytics. And one of the big challenge that we have in Vale is transferring mine material from South America to China, because it's the final customer that we have. And we need to charter the vessels, and we need to transfer this mine material, speaking about iron ore and nickel, from Canada or from Brazil to China. And Vale has around 1,800 voyages every single year to move this material. As you know, a main part of the final cost of our product depends on the cost of the shipping.
Yeah. Yeah, transportation is very, very expensive, and that goes for iron ore and trains as well.
Yeah, just for example, to charter a vessel, you need to pay around $35,000 per day.
Oh.
And one voyage takes around 36 to 40 days from Tubarão is a port in Brazil to Shanghai in China. And you can imagine it's a billion dollars, the cost of shipping. And now the question is that how AI can help us to reduce this cost is important.
That's an
So
incredible
we are
amount of money.
exactly. So we are focusing on three aspects of this challenge. The first is about predicting the time chartering or TC, because the pricing of spot fixing of vessels is highly variable and change day to day. Currently, there is no sustained way to determine which day or time is better to procure the vessel. And the aim of this project is developing a forecasting model to determine which period, current or future, is the best to procure spot vessels to reduce the shipping cost. As a potential solution, consolidate shipping and vessel data from multiple intelligence sources, same as brokers, third parties, Reuters, Bloomberg, and so on, can help us to use the machine learning models to predict the TC rate in different windows, for example, weekly, monthly, quarterly, and find the best time to charter a vessel. This is the one project that we are working on that, and we reached a very successful results. And the second project in this area is about predicting the supply. It means that now we have an application to track the vessel movement in the ocean. And now we can estimate and we can predict the number of the available vessels in different areas to charter.
Speaking of supply, does that also regress into the management of what quality of ore is made available at the port and managing the product stream and not only the transportation process?
Yeah, it's a multidimensional project. We not only can predict the vessel availability in different ports, we can predict the quality and the quantity of the material that will be available in the ports to transfer. It's just for supply. In demand, we have also, it's the last project that I'm working right now in the shipping area. In the demand area, we are working on another application to predict the demand of vessels in different areas, because we have other competitors, for example, BHP, Rio Tinto, and they need a vessel. They need to charter the vessel to send their material across the board, and they need to charter the vessel. So now our application can predict their demand for vessels. Now we already integrated these three projects together: TC rate, prediction, supply, and demand together. And now we not only can find the best time to charter a vessel, we will have access to the best time for the vessel availability, the material in the port, and also the competitors' demand.
So from where I sit, it seems like the worlds of AI and ML both are highly dependent on access to data, specifically, of course, for ML, and then the creation of models that allow us to simulate enough of reality and train and eventually describe the world to our AI engines. So in mining specifically, there seems to be lots of data, but an incredible lack of information. Now, I don't know if you know this, but MineWarp plays heavily in this world of mining technical data amalgamation and integration in order to improve the quantity, the quality, and the completeness of the data that describes the mine. And this includes, again, from the mineral asset to any moving assets that are on the mine. And you recently published a paper in which you outlined a strategy for advanced analytics maturity assessment, which I think is really necessary, because you've got to know where you are before you can figure out where you want to go. In this paper, you addressed some typical problems that mines have when they adopt AI type technologies. Can you maybe elaborate on some of these problems that that you see that minds have as they grow through the maturity curve to be able to really capitalize on the capabilities of AI?
Yeah, for sure. As when we present the benefits of using AI in the mining industry, all mining companies and the mine managers so excited and they wanted to use it. Say, Ali, it's a fantastic job. We need this application. We want to use it. But I should say it's not possible. It would be a dream if you want to copy and paste any applications to use in the different mindset. Maybe one application works in one company and country very well, and in other company it doesn't work. So to solve this problem, because we are looking for the sustained and scalable product in AI, we don't like just to make an application for one mine site when we cannot use this application in other mine sites. So it doesn't make sense for the management to invest in this field when they cannot reach to the scalable product. To solve this problem, we already introduced a maturity assessment. What's the maturity assessment? When we are speaking about the advanced analytics, we have 7 levels of maturity. The first level is related to the raw data. It means that the company has access to the raw data. It's a very noisy data and the messy data, and we cannot extract any information from this data. The second level of the maturity is about the cleaned data. It means that we are using some applications to reduce the noise, to delete, to cover the gap, and so on. The third level of maturity is about the standard reports. It means that we not only have the clean data, but also we already extract some initiatives and ideas for improvement from the data. All of these 3 levels and the half of the next level, that is the generic predictive analytics, are located in one group that I say sense and respond.
Right.
It means that you need first sense and then collect the data, find the problem, and then making the solution for that. And I need to say, all of the mining companies right now located in this area, sense and respond.
And this is descriptive analytics mostly, right?
Yes, exactly.
Yeah.
But the fourth level is about the generic predictive analytics. The company is using some the general and some normal analytics method for visualization using Power BI, plotting the graph and something like that. But they need a human to interpret the results. The 6th level of maturity is about the predictive modeling. It means that in this level, we can answer this question, what will happen? Not why did it happen and what happened. Now we can answer this question, what will happen?
Given what I've learned about what I've done, if I carry on in this way, what's going to happen?
Exactly. And the 6th level is about the optimization. When we can answer this question, what is the best that could happen? And we can optimize parameters to improve the efficiency. And the last level, and the 7th level of maturity, is not reachable right now, is the decision making, because we need the strong AI and general AI to touch that level. It means that the advanced analytics model can make decision and they don't need a human as a supervisor.
This could be, I guess, also generically called prescriptive analytics. Is that right?
Exactly. Yeah. So, but all of these levels, I'm speaking about level 6, level 5, 6, and 7 are located in the predict and act group. Yeah. So we can predict. This is the 7th level, but we need to assess and we need to evaluate the mindset for 4 dimensions in 7 levels. When we want to improve and use the usage of AI. We need to focus on 4 dimensions. The first is data. It's very important. The second is technology. The third is system. And the last one, and the very important one, is people. The best AI model, when the people don't like to support this application, definitely you cannot use it. And it would be the rubbish. So you need to you need to make sure you already reach the level of the maturity for the people that they can digest this type of the new technology, and they can believe this technology can help them to be more useful in their work and their job. So this as maturity assessment can clarify your as-is situation based on these 4 dimensions, and can clarify the to-be situation that you need to reach it, and find the gap between the as-is and to-be. And after that, this assessment can help the management to have access to some recommendations to transfer from as-is to the to-be condition.
We could spend hours and hours more talking about this and the application and so on, and why things work and don't work. But unfortunately, we have run out of time, so we've got to bring this to a close. And we normally do that by asking our guests what's on their bedside table. Now, besides all of the many books that you've already been writing yourself and participated in closing, then, what are you reading? What's your bedtime reading?
Yeah, definitely. I'm reading some books related to my passion, that is AI, but in other side, I'm thinking about the human life in the future, because I don't like just to focus on industry. You mentioned that I was very active in the field of education, publication, and completing the business projects. But for reading, now I'm reading some book related to the future of human. For example, I completed the Life 3.0 book wrote by Max Tegmark. And the title of the book, Max, is about the being human in the age of artificial intelligence. And also I'm reading some books by Yuval Noah Harari about the philosophy of the future. I'm now reading. I'm in the middle of the book. Homo Deus is a brief history of tomorrow, and I recently completed the 21 lessons for the 21st century, completed by Noah Harari. And one of my other favorite book is Everybody Lies. It's my favorite book.
Well, why should we believe you? I don't think it's your favorite.
No, I strongly recommend you to read that book, because in that book you can find what the internet can tell us about who we really are. And it's into internet. So yeah, I'm just reading these books right now. I have a lot of books open in my desk, but everything is related to the future.
Excellent. Dr. Ali Soofastaei, thank you again for being our guest today. It was most interesting, and I'm sure we look forward to not only watching where you're going with all of the new innovations that you're bringing to the mining industry, but in general, also looking forward to see things becoming safer and more productive on all of the mining operations that most of our listeners spend the majority of their time on. Thank you so much for being our guest. I really enjoyed it.
Thank you. Thank you so much for your time and for this opportunity that you already gave to me to speak about my passion and about the AI applications. Thank you so much, and have a great day.